Okay, so for the last few days we've been practicing these sort of sketches. So what I'm going to ask you to do now is spend the next, let's say, 5 to 10 minutes, and I want you to practice this sketch here. Remember, you're going to look for vertical asymptotes, do test points on either side to check and see if they go to positive or negative infinity. Horizontal asymptotes, if there are no horizontal asymptotes, look at oblique asymptotes. X and Y intercepts, and then taking all that information and your experience to do a sketch. So I'll ask the supply teacher to just pause the video now, and we'll give you about 5 to 10 minutes to everyone try it, and then we'll take it up in a second. Okay, so I'm going to run through this relatively quickly because you've had a chance to try it on your own, and we'll be able to just compare with the stuff you have. If at any point you have a question or don't understand why I did something and the video is still going on, don't be afraid to put up your hand. The supply teacher can pause it, and then maybe someone in the class can help explain that step. But let's go through this relatively quickly. So before I go off and find any asymptotes, best thing to do is to simplify this. So we're going to go x cubed on that, and we're going to factor this. This is difference of squares, so x plus 1 and x minus 1. That'll allow us to make it easier to find vertical asymptotes. So there's 2 spots where we can find vertical asymptotes. There'll be one at -1 and one at 1. So we're going to do test points on those right now. So I'm going to pick a point. Oh, actually, let's graph them. So there's going to be an asymptote at -1 and an asymptote at 1. Now we'll do test points on those. So I'm going to pick a point to the left of -1, so that's 1.1. And to the right of it is going to be -0.9. I'll sub these in and see if they go to positive or negative infinity. When I plug in a negative in the top, it's cubed, so it'll stay negative. Positive, or it'll go negative, negative, negative is negative. On the bottom, -1.1 plus 1 is going to go to negative. The plus 1's not enough to get us back to the positive side. And then -1.1 minus 1 still stays negative. On the bottom, I'll have positive. A negative divided by positive is a negative infinity. So over on my graph, just to the left of the first asymptote, it's going to go down to negative infinity. I'm going to guess the other one goes up, but that's not always guaranteed. Let's check here. So -0.9. If I cube that, again, it'll be negative as well. And then -0.9 plus 1. Now it goes into the positives because the plus 1's bigger. -0.9 minus 1, of course, just stays negative. So I have negative on the bottom. Negative divided by negative is a positive. And as I expected, I go positive infinity, and so I've got this happening. Now I'm going to do a test point on the left and right side of my other asymptote at 1. So the left side is 0.9, a positive 0.9, and the right side is going to be a positive 1.1. So when I plug in a positive, cube it, it's going to stay positive. On the bottom, positive 0.9 plus 1, of course, is positive. But 0.9 minus 1 is actually going to go negative. So I'll have negative on the bottom. Positive divided by a negative is negative infinity. So at 0.9, I'm going to go down to negative infinity. So I wasn't sure on that one, so that's good. And now I anticipate it's going to be positive on the other side, but we'll see. 1.1 cubed is positive. 1.1 plus 1 is positive. And 1.1 minus 1, of course, the 1.1 is bigger, so it's going to stay positive. Everything's positive. Positive divided by positive is positive. And indeed, it goes off to positive infinity. Next, we're going to check our horizontal asymptotes. So for the horizontal asymptotes, I need to get a n and an m. N is the degree of the denominator, or excuse me, the numerator, which in this case is 3. M is the degree of the denominator, which is 2. So n is greater than m, so therefore there is no horizontal asymptote. But we do have the special conditions that this is n is greater than m by 1. So there could be an oblique asymptote. And this is what we did yesterday. So now how do we check and see if there is going to be an oblique asymptote? We actually do the long division. So I'm going to do the long division and actually divide this. So it's, we start with x cubed, which is x cubed, but of course I need all the placeholders, so 0x squared plus 0x plus 0. So it's that being divided by x squared minus 1. So I'll need the placeholders on this one too, x squared plus 0x, oh not plus 1, minus 1. So it's x squared plus 0x minus 1. So I'll do my long division here. I'll ask what number do I multiply by x squared to get x cubed. So that's obviously x. So I go down here. Rainbow, x cubed plus 0x squared and minus 1x. Subtract. This is 0 minus minus 1. So that becomes positive 1x. And that's as far as I can go. I could break down this, but because this is only an x and I'm dividing by x squared, that is my remainder there. So I'm done. I don't really care about the remainder. What I discovered yesterday is that the vertical asymptote is given right there. Or sorry, the horizontal oblique asymptote. So the oblique asymptote is y equals x. Well, what does y equals x look like? Well, that's a straight line right from the very first day of this class. We graphed y equals x. It's a straight line. It goes through 0, 0. Its slope is 1. And so I can draw that. And there it is, going through 0. Just going to make it a bit longer. And there's the oblique asymptote, y equals x. Now, of course, that's all we know. Calculus will allow us to determine whether the graph comes above or below the oblique asymptotes, but right now we're just going to have to draw on experience. So we can do a little bit more, though. We've got our vertical and horizontal asymptotes. We can do the y-intercepts, which is when x equals 0. This is the math that's really easy. I'm going to plug it into the original. So it's 0 cubed over 0 squared minus 1. So that's 0 over negative 1, which of course is just 0. So there is a y-intercept at 0. And then x-intercepts, well, if there's a y-intercept at 0, then there's going to be an x-intercept at 0. But let's see if there's anything else. So this is where I set 0 equal to my function. Remember that this bottom part disappears because it gets multiplied by 0. So I'm just with 0 equals x cubed. If you want x by itself, you're going to take the cube root of 0, which of course is 0. And as anticipated, I already have that x-intercept of 0. So there I have it. There's all the information I know. The rest is going to be from experience. I'm going to look in the top right here, and you see I have the going off to negative infinity right here. Chances are then it's going to go off like this and make a little loop. So let's actually draw that. That same idea is probably going to happen in the bottom left. I have this going down to negative infinity, and chances are then that this is going to go down like this. So I'll have a similar sketch happening down here. The middle one we have a little bit more confidence in. We know it goes off to negative or positive infinity over here, negative infinity over here, and it goes through 0, 0. And we know from experience it's probably going to look like cubic. And there we have our sketch. We can do a test on this to check on the graphing calculator, but I'm confident that this is what it looks like. So that's a good warm-up.